I believe you can see my screen now as well. So, of course, thank you very much for giving us a background on what we are doing as a group in the University of Pretoria. So I'm just quickly going to share with you some of the products or the applications that we use in our department with regards to XR and the training in that. So when we started this whole facility, it was actually just a glorified PowerPoint or a slideshow presenter, which has the 3D capability. But over the last 7 or odd years, excluding the COVID years, a lot of thought went into how can we immerse the mining engineering student into the academia side in the context of mining, and also then to put them in dangerous situations which are endangering their lives. So I'm just quickly going to touch on these 3 topics. Quickly going to run you through our teaching facilities, the things that we have to show the students, then show you some of the applications, and throughout the slides I will quickly talk and touch about the research that we found between myself and Koos and his team on the way going forward, and as we've developed all these type of things. So since we started the facilities at the university, I mean, the mining department has been the people exposing people to the XR and the immersive technologies, and I think that was the incubation of the toy box that Koos developed with the health sciences and in their library, because people don't know what the facility can actually do or what the technology can do, and therefore they can't find any application in their field for this technology. So the first room that we have this 3D cinematic theater, which is a nice and widescreen projection. I have the 3D capabilities showing that. So once we develop the information or the visuals for students, we can immerse them into a bigger screen than just the laptop or the platforms that they typically use with the cell phones and the tablets. So if you get in our facility step next door, we have this big 10-meter diameter cylinder, which has the same environments or same mining methods that we show on a flat screen. We can then wrap around them. So we have a full 360, a 3D display. We can put people from various mining environments, mining methods, can show the surface mining situation, the full mine cycle. We can put them 4,000 meters underground without breaking a sweat. So we can actually show them what the mining environment will look like towards their studies and the outcomes of that. One of our flagship applications is the AR mobile visualizer. So we have built a system where we use the device, as you can see on the video, a device where students are, while they are studying using the notes, pick up the device, scan over the page, and the visual links then opens up models. Now, I mean, these days, this is common and can easily be found on any other application stored for your device. But when we started this, I mean, this was really cutting edge for the students, and I still believe they at least look at the models 3 times. So the moment they download the app, the second time when they actually start using it to study, and then maybe show it to the partners and even the sponsors who pays for the bills. So at least 4 times students get to see the models, and hopefully enhances the learning curve towards the technical content that we try to bring across to them. Another application that we show students typical geological hazards underground. So in this training room or in this museum, there is different podiums, so they can navigate themselves in the VR space between those. Every plinth then shows a model of a specific hazard. You can then look at the model in 3D space as it rotates around you. You can understand that. At the bottom there, you can see there's a small little tablet. So on the tablet, the theory is written to them, so they can actually read the theory and understand how it all comes together. And once you've seen that, you can interact with the model, and then it loads you into the underground environment where you need to walk a certain distance in the underground simulated area and then identify that. So our belief is if you can identify the hazard, you will most probably not going to enter into an area which is life-threatening. Some other applications that we have with regards to rock breaking or the blasting engineering side, we have this mobile manufacturing unit, or explosive truck for short. So in this, a student or a candidate needs to make his way around this truck and then identify on the checklist 37 items, ranging from the easy non-technical stuff like checking for a crack on a windscreen, or look at the tires or the the conditions of the wheels, to more technical aspects like the pressure burst pipes, the augers, and the places where the tools are kept. So in this way, the student, they get to know the machine, get to understand where to look for when filling that checklist. And every time they load this application, the whole truck, the 37 items, get randomized. So I can watch on your screen as you complete your checklist. When the moment I get my checklist, there will be a different vehicle in front of me, or different conditions of the same vehicle. Then we have a interactive blast wall. Also, again, on the blast engineering module, we teach them how to design for a specific rock mass and how to cater for the explosive part around it. So you need to design your pattern, then go out and mark your pattern on this virtual wall. Then on the holes that you actually now simulated as a drill, you need to time them. In explosive wise, there needs to be a certain sequence of which your actions or your holes need to be blasted and detonated. And then we simulate something there to the bottom right. You can see this, the picture there simulating a little blast. So it shows you that if you either mistime your blast or didn't actually charge it with your virtual explosives, there will be consequences to your actions or non-actions for this case. Let me just see. Okay. Then also, Koos mentioned about the scenario training or the branch narratives that the health sciences work. That is actually a spin-off of what we start with at the mining department. So we had this 360 in-video assessment where my request was for Koos that I don't want to have a developer every time I want to create a scene for my students. So I would need to go out, take some 360 photos, to be able to upload that into my platform, generate a question with a memo, and then push that to the students for actually completing and see if they can identify the stuff that I want them to notice. So this application then was born, and then I can now go out with a standard off-the-shelf 360 camera, take a photo or a video clip, load that into the application with a certain question. For instance, example, the two pictures, that the top one, I marked the faces to the north side of the pit, and the student get the question, indicate the faces to the north side of the pit. So there you see the green highlights, tells me that the student can orientate himself with regards to the directions in a surface operations. So that is our department and the work that we are doing. Through the years, with all the countless days that we spent in there exposing students and staff members to what the technology can do. I mean, that's really what it is. And the focus is first to identify the technologies for use, and then let the people start playing around with it, because the more they can see the application or the tools around and available, the more they can bring it to their screen and see how they can actually find fit for that in their environment. Okay.